These are the video notes for 6.6 solving quadratic equations. In order to solve a quadratic equation, we need to define what a quadratic equation is. A quadratic equation is a polynomial equation to the second degree. We have the form ax squared plus bx plus c equals 0, where a, b, and c are constants and a does not equal 0. We will be using the zero property rule, which says if a times b is equal to 0, then a equals b, or b is equal to 0. I have the steps laid out for you to solve the quadratic equation. The first is simplify both sides of the equation if possible, set equation equal to 0 if it is not, factor the polynomial, use the zero property rule by setting each monomial or binomial with a variable to 0 and solve, and finally check solutions. Let's take a look at our first example. N squared plus 9n plus 14 is equal to 0. It is a quadratic equation, a polynomial that is to the second degree. We look at our first step, simplify both sides of the equation if possible. Since both sides of the equation is already simplified, we can skip step 1. Step 2, set equation equal to 0 if it is not. The equation is already set equal to 0, so we can skip this step. Factor the polynomial. So we have a trinomial on the left side of the equation, which is going to be factored to n plus 7, n plus 2, and then we bring down the equal 0 sign. Next is the zero property rule. The zero property rule states again, if a times b is equal to 0, a is equal to 0, or b is equal to 0. This represents a, this represents b. What we're trying to do is to find which value of n would cause the binomial to be 0 so that we would get a product of 0. So what we do is we set each binomial equal to 0 and solve. So n is equal to -7 and n is equal to -2. We have two solutions to this equation because of the degree. The degree indicates how many solutions you will get. In our last step, check solutions, what we should do is, for each of the values that we got, we're going to substitute it into the original equation. So n squared, -7 squared, plus 9 times n, 9 times -7, plus 14 equals 0. We're going to simplify this using the order of operations. And we got that 0 is equal to 0, so we know that n equals -7 is a correct solution to this quadratic equation. Now we're going to do the same for -2. -2 squared plus 9 times -2 plus 14 equals 0. Since 0 is equal to 0, we know that n is equal to -2 is also a solution to this quadratic equation. For the rest of the examples that will be shown in today's video lesson, we will not be showing the check work, but it is encouraged that you check all your solutions each time you solve a quadratic equation. For the next example, we will not be skipping step 1. We're going to simplify the left side of the equation by distributing the n. And then we're going to move on to step 2, which says set equation equal to 0. Since the equation is set equal to 24, I'm going to subtract 24 on both sides of the equation. Now I'm going to proceed by factoring the polynomial just like we did in the previous example. Then finally, we're going to use the zero property rule. Solve each equation. And we get n is equal to 6 and n is equal to -4. Next example, we are going to skip the first step and the second step, and we're going to proceed to factor the polynomial. To factor the polynomial, we're going to factor out the GCF 5x. Now we're going to set the monomial of 5x is equal to 0 and x plus 1 is equal to 0 using the zero property rule. So our two solutions is x is equal to 0 and x is equal to negative 1. For the next example, you will notice that the polynomial has 4 terms in it. We're going to skip the first 2 steps and move on to the third step, factoring the polynomial. If you recall from the previous lesson on factoring, when you have 4 terms, we're going to factor by grouping. So we're going to group the first 2 terms and the last 2 terms. Factor out the GCF, y squared. Factor out the GCF, negative 4. And then factor into y squared minus 4, y plus 3 equals 0. We're going to continue factoring the difference of perfect square, y squared minus 4, into y plus 2, y minus 2, y plus 3 equals 0. Since we have 3 binomials, we're going to set each binomial equal to 0 and solve. So subtract 2 on both sides, y is equal to negative 2. Add 2 on both sides, y is equal to 2. Subtract 3 on both sides, y is equal to negative 3. In this example, we're going to skip the first step because we cannot simplify either side of the equation. We're going to move on to step 2, where we're going to set it equal to 0 by adding 14 to both sides of the equation. Then we're going to factor the polynomial. Set each binomial equal to 0. Solve each equation. And get n is equal to negative 2 and n is equal to negative 7. In this example, we're going to multiply both binomials together to simplify. We will get x squared minus 5x plus 3x minus 15 equals 0. Some of you may know this as foiling or distributing. Then we're going to combine like terms. Then we will proceed to factor the polynomial because it's set equal to 0. Then take each binomial, set it equal to 0, and solve. And when we solve, we get x equals negative 3, and x is equal to 5. If you notice in this equation, the way it started, we technically did not need to simplify both sides of the equation. And if you look here, it was the same step as we had down here. So if you ever have a problem that starts off with 2 binomials equaling 0, you can jump right to step 4 and take each of the binomials, set them equal to 0, and then solving for x, which in this case gave us x is equal to negative 3 and x is equal to 5. In this example, we will need to simplify both sides of the equation. We're going to multiply the 2 binomials together. Then combine like terms. Then we're going to set it equal to 0, so we're going to subtract 21x, subtract 3x squared on both sides of the equation. We will end up with 2x squared plus 3x minus 5 is equal to 0. Now we're going to factor the polynomial. We need to factor this by using the AC method. Then we're going to factor by grouping. Factor out the GCF of 2x. Factor the GCF, which is x minus 1. Now that we have completely factored the polynomial, we're going to use the zero property. We will get x is equal to 1. And then here's a two-step equation. And x is equal to negative 5/2. In our final example, we will skip step 1 because both sides of the equation have been simplified, skip step 2 because it's set equal to 0, and we're going to factor the GCF 2 from the polynomial. Then we're going to factor the trinomial, into x minus 3, x plus 2, and then we're going to set each binomial equal to 0. We're going to ignore the 2 here because the rule says we're going to set each monomial and binomial with a variable. The 2 does not have a variable attached to it, so we're going to ignore it when we solve this equation. Add 3 to both sides, x equals 3. Subtract 2 on both sides, x equals negative 2.